All algebra expressions and equations can be plotted on a graph. We do this because when we are looking at algebra, we don't always know what x is. X could be your height, and then plus 2 could be that little extra that you add on for your shoes. Depending on the person, how tall they are, is going to change how tall they are with their shoes on. Now, everyone is a very different height. Very few people are the exact same height. So we're always going to get a different answer depending on which person we look at. Now, if you can imagine doing this for every single possible height you can think of, that would take an incredible amount of time. So instead, what we can do is we can plot on a graph how this relationship works. So I have my y-axis and I have my x-axis. Now, here I have some values of going up by ones. And then I have some negative values, and then some more negative values going down here. So if we have a value of x equals 1, what does y equal? Well, y equals 1 plus 2, which is equal to 3. So when x is equal to 1, y is equal to 3. So x is 1 and y is 3. So we've done 1 point, one of infinitely many points. Now, what if we do another one? Let's say x is equal to 0. Well, this is going to equal y is equal to 0 plus 2, which is equal to 2. So we can plot that point. So x is 0, y is 2. Now what about when x is equal to 3? So y is equal to 3 plus 2, which is equal to 5. So when x is 3, y is 5. I'm going to go up here. Now I could do this for every single number, but that would take forever. So instead, I have my 3 points. Now we can see that these are a pattern. They're all in line. If I was to draw a line, it goes up, and then this will go down through here. I can now see all the values of x and where they would be on this line. And so if you ended up all the way up here, you could go, well, what's my y? My y is over here. And what's my x? Well, my x is just down here. So we can just instantly find an answer by looking at this graph instead of having to calculate it. So how do we get this rule here? So let's have a look at a new graph. Right, so I have some points. So if I have a point here, a point here, and a point here, we can see that these 3 points are in line. So that means that there's a pattern going on. So there's going to be a way to mathematically write that formula, because we can always describe every pattern with maths. So we use this form, y is equal to mx plus c. Now, if I start off at 0 and I add 2, and then I add 2, and then I add 2, and then I add 2, we could say that the rule is y is equal to 2x. Because every time I've added 2, I've ended up with a multiple of 2. So if you think about it, if every second you take 2 steps, then after 1 second, I'm going to take 2 steps, because in your head, you just do 2 times 1. If after 3 seconds, how many steps would I take? Well, I'd take 1, 2, 3, 4, 5, 6. So if I was to put that into the formula, it would just be 2 times 3, which is just 6. But sometimes we don't always start at 0. So what if I started at 5 steps, and then I took 2 steps every second? Well, then I would have 2 steps. After 1 second, I would have 2 steps, and I also have to add 5 to it. And after 2 seconds, I would take 4 steps, but I've also got to add 5 to it. So every time, I've still got the same thing, but I have a constant out the front, or at the beginning, that says I've started at 5. And that's really important. So if I started at 5, that would mean my rule would become plus 5. So I take 2 steps every second, but I'm at 5. So let's have a look at this graph here. So I've started at 1, 2, 3, 4, 5. So I've started at 5. But instead of going up, I've gone down. So what is my rate of change? Now, what am I doing every time? So we know that we've started at plus 5. So what has happened after one change going across is I've gone down 1, 2, 3. So I've gone down 3. So using that example before, I've started at 5 and I've walked backwards 3 steps after 1 second. Now, this rate of change, or this also known as the gradient, so let's write gradient, when represented on a graph, is how much we go up or down divided by how much we go across. So this, we've gone down 3, so that's going to be a negative 3. And then we've gone across 1. So that's going to be divided by 1. So that means that our rate of change, what I've done every second, has just decreased by 3. And we also know that we've started at plus 5. So that means, based on that example before, we can write y is equal to minus 3x plus 5. So this pattern of how it changes, this gradient, or also known as rise over run, so up or down, over across, is negative 3, but we started somewhere. We started at plus 5, so that needs to be written there. Hopefully that explains a little bit more about gradient and a little bit more about how to think about these graphs and these equations.